Okay, so now this is continuing on limits. So what if we run into a condition like in the previous section, like 1 over x? So in this, the limit doesn't exist, right? There is no, it's not there. And there's 3 reasons that the limit cannot exist. 1, the limit does not exist because the one-sided limits disagree. So one-sided limits disagree. 2, and I'll talk about what each, well, okay, I'll talk about what this means. So what does this look like on a graph? On a graph, this looks like if this comes up like this, and then it continues like that, and this is both at x equals 3, as you approach from the right, the limit of delta x approaches 3 from the right, when it goes to 1, and here it goes, the limit as delta x approaches 3 from the left, and this equals 1, and this equals 4, the one-sided limits disagree, so there's not a limit there. The second condition is the condition we have here, so it's unbounded. So I don't know what the graph of this 1 over x looks like. I kind of do. It's going to start off at 1. So at 1 it'll be 1. At 1 it's 1. As it gets infinitely smaller, it gets infinitely bigger, so it looks like that, kind of. So the graph probably looks something like this. But it never, at 0, it doesn't exist. It does that. So this is like a hyperbola. But at 0, the graph 1 over x is undefined. So there's no limit there because it's unbounded. There's no value for the graph at that point. Right here we have a vertical asymptote, so that's the reason. It's unbounded. Another reason, third reason is oscillating behavior. And this is like in your sine and cosine functions. So if we're doing this thing, there's no limit. There's just no limit here. Let me think about why for a second. Because if there's a limit here, the limit here equals the limit here. And it goes, because it's going back and forth, there's no point where you get super close and it stops. Right? If that makes sense. Oscillating behavior, no limit. In the next video I might have a reason for that, I don't know. And also something I left out of last video was find limits analytically. So find limits analytically. So what we've looked at here is graphs, so we can look at what it's doing. Analytically spelled wrong, I know. You can look at it through graphs or with a table. So when you find a limit, you can find them using a graph, using a table. Those aren't analytically. Analytically is finding them how we discussed in the part 1 video, using direct substitution, reducing, rationalizing with a conjugate, and the trig limits. So basically using math to find the limit. That's finding it analytically. I hope that was helpful.